Hey everyone. So remember, we are beginning the process of switching over from confidence intervals to hypothesis tests. And we are on topic 3 of your big ideas for Unit 6. And I want to take the time, you have your sentence frames, and we've already started to use these sentence frames over and over again. But I want to talk a little bit about this concept of one-sided and two-sided hypothesis, p-values, how to make a conclusion, and what's called a significance level. So let's get started. So to start with, a hypothesis test, a hypothesis test is about answering the question, determine if the sample results could happen simply or purely by chance. Okay. And so we've been using simulation results in order to do that and to have that conversation. And kind of going forward, the idea is that, well, maybe I don't have to use simulation results. I can use the fact that I understand that the data is approximately normal or something else, and maybe I can use those results to compare to what would happen. Okay. Big things to kind of take away to start with is that we keep around the same conditions. So the idea of normal, random, and independent is sticking around. And we're going to come back to that. But just for you to know, they're not going anywhere. And for now, we spend most of our time talking about p-values, notations, and things that are slightly different. So one of the new things that we saw was the idea of a null hypothesis. Okay, so a null hypothesis, which is H sub naught, and it always is either a p or a mu, and it's equal to the value in the claim, which we call the null value. Okay, so it's the problem like the 0.84 in one of the questions, or the 0.8 for free throws, or the 1/3 from the conversation about discrimination. Okay, it's always equal, always about a parameter, and always to the null value. Okay, these are parameters, p and mu. There's no hats, there's no bars. They don't get to wear anything fancy on top of their heads. Okay, always have that. When we move from null, we then go to the alternative hypothesis. H sub A, and that can be a p or a mu, but it can fit one of 3 circumstances. And I'm going to draw a picture over here to go with each circumstance, which is why I am kind of going. So they are greater than, less than. It would help if Miss B draws her pictures correctly. Greater than, less than, or not equal to. Okay, so greater than and less than are called one-sided tests. These are one-sided. And this one is two-sided. As a picture, okay, so this is kind of the first time we're going to see this. As a picture, if I was to draw a normal curve, a confidence interval deals with the inside. Hypothesis tests can deal with the outside. But here's the thing, and this is where it's key. A one-tail and a two-tail test deal with the area here and here. So this is a greater than, and this is your less than situation. Okay. A two-tailed test looks at that traditional picture with my horrible normal curve and says, what about both sides? Very similar to the kind of reverse of a confidence interval directed. Okay. The other really big key conversation is how do we determine if we reject or fail to reject? Okay. So we say that if the p-value is less than alpha, and remember that alpha is the significance level, we therefore, remember 3 dots means therefore, reject. There is significant evidence. Reject, there is. If the p-value is greater than alpha, therefore, we fail to reject. There is not significant evidence. Okay. And of course, my favorite saying of all time to help us remember all of these lovely things: when the p-value is low, reject the null hypothesis, or better known as when the p is low, reject the hoe. Hope this helps, and I will see you soon.